1.1 Propositions and Logical Operations. Logic is the study of formal reasoning. A proposition is a statement that is either true or false, but not both. Oops, there's no E there. As an example, we might use something called propositional variables, which are just variables, which are letters representing a thing, but instead of representing real numbers or a set of numbers like they often do in algebra, they represent propositions. So for example, P might be the proposition, it is raining, and Q could be the proposition 1 plus 1 equals 3. Again, these two letters are propositional variables. It is raining. It could be either true or false, but not both. At the moment, it is false because it is not currently raining. And of course, 1 plus 1 equals 3 is a false statement. It's still a proposition. It's just false. So speaking of which, a truth value is the proposition's truth value is a value indicating true or false. That's it. So don't make it too scary. Indicating true, usually with a T, or false. So if we look down here at an example, we have the proposition 2 plus 2 is 4. Its truth value is true. 2 plus 2 is 5. The truth value is false. Monday will be cloudy. All right, well, that is either true or false, but not both, but we might not actually know what the answer is. So that's unknown. And the movie was funny. That truth value is a matter of opinion, so that wouldn't count as a proposition. A compound proposition is created by connecting propositions with logical operations. And a logical operation combines propositions using a particular composition rule. Our first logical operation is the conjunction, P and Q. And the notation for that is as follows, with a caret pointing up, and it's read P and Q. So from our previous example, if we have it is raining, and actually let's go ahead and let Q be something different. It is cold. Then of course, P and Q would be the compound proposition. It is raining, and it is cold. A truth table is exactly what it sounds like. It's a table of truth values, and it shows the truth value of a compound proposition for every possible combination of truth values. Every possible combination of truth values for the variables contained in the compound proposition. So this will be a finite number of possible combinations because the only possible truth values for each of these propositions is true and false. So here's how we build a truth table. If we're going to do a truth table for P and Q, then here we're going to list P, Q individually, and then we have the compound proposition P and Q. Now we need every single possible combination of truth values. So we think about, okay, how many ways can we have trues and falses between P and Q? So you might want to pause and think about that. The number is going to come from 2 to the number of propositional variables we have. So if you have 2 propositional variables, then we will have 2 to the 2 equals 4 rows. If you have 3 variables, then we will have 2 to the 3, which equals 8 rows, and so on. So if we know that we are going to have 4 rows, then we're going to take half of that, which of course is 2, and we're going to list under our first propositional variable true, true, false, false. Always do it this way. And the last propositional variable, in which case is Q, even though it's only the second one, is always going to alternate. So Q is going to go true, false, true, false. If there was anything in between, then we would keep taking that half of 4 and having it until we get all of the possible combinations. So we have true, 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 false, false, true, false, false. Now think about what it would take in order for it is raining and it is cold to be a true statement. So if it is raining and it is cold, then yes, it is raining and it is cold will be a true statement. However, if the statement it is cold is false, then it would be false to say it is raining and it is cold. Likewise, if the statement it is raining is false, then it is raining and it is cold is of course false. And then if both of those two propositions are false, then of course the statement it is raining and it is cold is going to be false. For our next composition is the disjunction. So probably not too surprising that that's going to be the or statement. So that is denoted as follows with a little v or a caret pointing down, and we read that as P or Q, and this is called the disjunction of P and Q. Let's go ahead and add that to our truth table up here since we already have it halfway built. So P or Q. So if we were to just kind of follow up from before, P or Q would be the statement, it is raining or it is cold. So think about what conditions must be met in order for that to be a true statement. If it is both raining and cold, then in this situation, this is actually an inclusive or. This would still be a true statement. So yeah, it would be true that it is raining or it is cold, or potentially both. Or both. If it is only raining but it is not cold, then the statement it is raining or it is cold is still true. If it is not raining, but it is cold, then again, the statement it is raining or it is cold is true. The only time where this disjunction, this or statement, is going to be false is if both of those statements are false. So if it is not raining and it is not cold, then to say it is raining or it is cold will be false. The disjunction is also known as inclusive or. So it is the same as the disjunction and evaluates to true, as we have seen, when one or both of the propositions are true. There is, of course, such a thing as an exclusive or, and I'm sure that you have dealt with that in your computer science backgrounds, but we will not be focusing on that in this class for our purposes of logic because we have a lot of other things to talk about. A negation is written as follows. It's actually written a couple of different ways. So we can also write it as a tilde P. Sometimes that's a little bit easier, especially if you are typing, or sometimes we also put a bar over it, but that's much harder when it's typing, so we won't use that very often. And that is read not P. So however you want to denote it, we read it as not P. Since this is a unary operator, it's only going to have the truth table would be 2 to the 1 rows. So it would have P, and the possible truth values of P, of course, are just true and false. And then not P would then have the truth values false and true, respectively. This concludes section 1.1.